Hello, my name is Mr. Huang, and today I'm going to be giving you a lesson on polynomial long division, which is a topic in Algebra 2. So as I do now, we're going to start off with a long division problem, which may be simple for many of you, and may be quote-unquote simple for some of you. But please try your best, show all your work, and when you come up, if you do come up with a remainder, for example, if your remainder is 5, then please rewrite it as a fraction if you can. So if your fraction is 5 out of 8, please write 5 out of 8. So try this on your own, and then we'll go over it together. So as you can see, we are in a cyber environment, and in case people are not responding, they can go to what I call the Genius Room. And in the Genius Room, there's advanced material, as you can see, on L'Hopital's rule from AP Calc. So they can read through all these slides, and if they happen to get to the end, they would go to, they would see this slide here, which basically tells them that you need to move yourself back into the main room. So they can right click on their name and choose send themselves to the main room. And they may also be able to choose from here. So here we are back here, and I'm going to put the video back on so that you can see me. And alright, so now we do this by hand, and then I can show them a similar example. I would do it out, but the timing of this video is so short. So here's the title of today's lesson. I usually spend at least 2 days on this particular lesson, but that kind of can vary a little bit. And here in this lesson today, we will learn how to divide polynomials using long divisions, and we will also determine, we will be able to understand what this means if the polynomials are factors of each other. So right now, let's take a look at another example with manual long division. The one on the left here is color-coded. So as you can see, 37 cannot go into 8, but 37 goes into 85 2 times. So 37 times 2 is 74. We subtract that from 85, we get 11, and we continue that pattern on, and we end up with a remainder of 1. So of course, I might go through that a lot slower with students, but because of the video, this is just to give you an idea of what I would do in about a 5-minute session. Remainder of 1, this can be written as the answer plus 1 over 37, or we remove the plus sign as a mixed number, which is really a bad convention because this convention here does not follow polynomial long division itself, as you will see later on. So make sure you remember this convention here. On the right here, you have an alternative way of dividing the numbers. And it's okay to know alternative methods, but you must also know how to divide manually. So there may be some of you who maybe have never learned that or don't remember, but you do need to know that in order to help you understand polynomial long division much more easily. So usually I have another slide here for practice, but I'm going to skip that and just go right to this because this one already has all the steps written out. So let's say you have a big polynomial in what we call your dividend. So some big math expression divided by another math expression. And this is usually what we call our divisor. So what you do is you look at, you count how many terms are in this expression. We see 2 terms, the x and the 3, and you look at all the number of terms here. We see 4 terms here. You look at the term with the highest exponent here, which is x to the third. So we compare x and x to the third. X times what is going to give you x to the third? X times x squared is going to give you x to the third. So if you can't remember how to multiply polynomials or how to multiply something like this, you can go into this room, and let me just go one more slide over first. So when you multiply x cubed times the quantity x plus 3, you get this. So remember, we have this part here, which is x squared times the quantity x plus 3. And if you don't remember how to do that, some people on their own, they can go into this room whenever they need to. And I'm going to skip over to the multiplying polynomials here. So this is a quick reminder of how you multiply x squared times x to the third. And just a general reminder of an important exponent rule. And here's another example of how to multiply monomials, which will help with multiplying the polynomials. Going back to the main room now, and going back to where we left off, which is right here. So after you do that, then what we do is we put the signs in and we circle those signs, and then we put their opposite sign on top. So whatever sign is circled, you put the opposite sign on the top, and this column should always cancel out. Otherwise, you need to check your math, or you need to change this part here. This part here, since they both have x squared, we can add or subtract them. And then we bring the next term down because we want to, if we have two terms here in the divisor, we want two terms here as well. So there we go. We have the minuses there, and then you subtract and you get 7x squared. So after you get 7x squared, you drop the 31x down and you repeat the process. So you look for the highest term here, which is 7x squared, and x times what is going to give you 7x squared. We get 7x, and now we multiply 7x times x plus 3, and you get that right there. So again, this was 7x times x plus 3. And in case you're having trouble remembering how to do that, you can go into the multiply polynomials room as mentioned earlier. And to finish this off, so we circle our signs, change the signs, and we get 10x. So this should be moved over a little bit, but the lining got messed up. So we drop 32 down, and remember there should be two minus signs here. I'm not sure what happened to them, but yeah. So we end up with 10x, 31x minus 21x is 10x. Bring down your positive 32. So x times what goes into 10x, and we can see x times x plus 3, the quantity, times 10. We multiply that and we get 10x plus 30. I'm going to close that window. It can always be opened back up by window show file transfer library if people need it. And then of course we change the signs. And you can see we change the signs, we get 2, and when we rewrite it, we get 2 over x plus 3. So in the class, I would, instead of just going through it like I am now, what I would be doing is I would be comparing this step, going back and forth between this slide here and the first slide here, this slide here, yeah. So it'd be going between this slide and the other slides where I show the process step by step, so that people can understand why the formula works, where the steps in polynomial long division are coming from, and not just that it's a process. So this is something I came up with on my own. I didn't find it in a book. I've never seen it in a book. It's just something that makes sense, and I'm always trying to do that. I'm always trying to encourage students to discover patterns and ways on their own, because not necessarily everything will always be in a book. And just to kind of finish things off here, let me look for my exit ticket here. Sorry, that's not the right slide. And here's my exit ticket here. So eventually I would have gone over if, you know, if something like this is a factor of something like this. So that means if something is a factor, you get a remainder 0. If you have a remainder, though, then it is not a factor. So I would let people do this problem on their own, maybe give them about a minute. I can set the timer here. So it's kind of nice to have a timer. Everything's just more or less kind of automated, but I have to still develop the PowerPoints and stuff like that. And then they get time, they answer the question, we go over it, and then I tell them what they're assigned. So an assignment slide might look something like this slide here. Alright, thank you so much for your time, and have a good day.